Alright, so now we are in the washer method. So we're going to take the region bounded by f of x and g of x, which we already figured out. We already know what this is. So the nice thing is we can rewrite this. I know that's g of x is equal to 1. I know I'm going from 1, or negative 1, up to 2, and back down to positive 1. But I'm rotating around the x-axis. So this is my x-axis right now. So this is like what we call a washer method. And the washer ends up looking like this. Where you have kind of a hole in the center of it. So we're creating something that has a hole right in the center of it. So this area right here, and even if we went down to negative 1, and if you drew that line, and if you mirrored this, it would rotate around this. So you're getting like a napkin holder, maybe. You know how you put your fancy napkin holders around the napkin, and sometimes they're weird designs, but they have a hollow center to them, so you can stick the napkin right through them. Everyone's looking at me kind of weird. So maybe you guys haven't seen those. That's okay. I can't get that off there. Something like this, where there's a hole in the middle of it. You do? Well, some of you looked at me like I was talking about something that was from a different planet. And that's okay. But we're creating something that it's parabolic in its kind of in its shape, but it's cylindrical in its shape too. So it would kind of be like this. It would kind of end up like this, where we would rotate it around the x-axis, and we kept on rotating. But there's a hole in the center of it. Well, we're taking this whole section here and we're rotating it. Here's empty space. And if we were to connect it, it would connect all the way around. So there would be empty space between the two of them. Now, the process is the same. The integral is going to be different. That's the only thing. So, 1, you're going to graph, which we did. 2, we get a representative rectangle. So build that rectangle. All right, now from the rectangle and the axis of revolution. In this example, it's the x-axis. We want 2 lengths. Length 1. We want to go to the outer part of the washer. Because the outer part of the washer is, like if this is the axis of revolution, we want to get to the outer part of the washer first. So, believe it or not, that's going to be, if there's your representative rectangle that gets rotated all around, what part of the rectangle is the outer part of the washer? The top or the bottom? The top. This is going to represent the top of the representative rectangle. So if I'm going from here to here, what's the distance from the x-axis, because that's where we're rotating from? What's the distance from the axis of rotation to the top? Yep, 2 minus x squared. Now, the second one that we want, the inner part of the washer. And the inner part of the washer is going to be this part right here. What part of the rectangle is that? The bottom. Now, have you guys noticed a pattern yet with finding out like areas between curves and I don't know, areas with known cross sections and anything that has to do with a representative rectangle? Have you noticed the pattern of figuring out the top and the bottom? So what's the distance between here? That's a 1. Now, the area of the washer is, I need to take the area of a disc, so, or the volume rather, so the volume of the washer. Alright, there's the washer. That's going to be the volume of the disc. Now, what do I have to kick out of the disc? Yeah, minus the small part. So it's going to be a difference of 2 different volumes. This is still going to be pi r squared w minus pi little r squared w. That's why we had a capital R in the first one and a little r in the bottom one. What do you think the capital R stands for? The bigger radius from the rotation to the outer part, and this guy is your smaller one. So R is your outer radius, little r is your inner radius. So now step 3 is build the integral to calculate volume. Now the integral is going to be from a to b pi big R squared, and then we had a dx, minus pi little r squared dx. And if we do some fancy factoring, pi's can come out, can't they? So pi will come out. The dx can come out because we can factor out a dx from both of them, and it just becomes the outer radius minus the inner radius. The outer radius squared minus the inner radius squared, which is essentially top squared minus bottom squared. So again, we're using the whole top and bottom idea. Now, in our problem here, what's the top? Yeah, so if we want the volume of this shape, we're going to get pi. We know it's going to go from -1 to 1. Or can we... No, we'll do -1 to 1. The outer radius was 2 minus x squared squared minus the inner radius, which was what? 1 squared dx. So we use that idea from geometry that, all right, we got to punch out the center. This is the whole thing. This is the whole disk. This is the center part that we're punching out. And that's going to give us the volume of the washer. And then we're adding up all the washers between -1 and 1. Now with this case, can we transform the equation because of symmetry to make our lives just a wee bit more easy? Yeah, we can make this equal to 2 pi, integral from 0 to 1. Now, let's just expand everything here. It'd be 2 because 2 parts, we're only gonna calculate 1 and then just multiply it by 2. Because this is a parabola, and parabolas are symmetrical. So this area is equal to this area. It's a whole lot easier to go from 0 to 1 than it is to go from -1 to 1. Because once we integrate all this, we're going to get x's and everything. So once we substitute in a 0, those are all gone. So we only have to do one step of algebra instead of 2 steps of algebra. Now, expand this guy. 4 minus 4x squared plus x to the 4th minus the 1 squared, which is 1, dx. Now, 4 minus 1 is actually what? 3. Alright, so my volume is going to be 2 pi times, now I have 3 here, because these two guys give me a 3. What's the integral of 3? 3x. What's the integral of 4x squared? Yep. So I get 4x cubed over 3. What's the integral of x to the 4th? X to the 5th over 5. And I'm going to go from 0 to 1. So yeah, it's a little bit of algebra, but we have mad algebra skills, so this ain't nothing. I didn't say I had good grammar, though. Alright, 2 pi. Let's plug in a 1. So I'll get 3 minus 4/3 plus 1/5. And put in a 0, what do I get? 0. Alright, so that's 2 pi times, now I got to figure out this garbage. Now what's the common denominator? 15. So I have 3 15s. Alright, 3 15s is 45, isn't it? 3, that'd be, 3 goes into 15 5 times, so that's 20. That goes in there 3 times, so that's 3. So 45 minus 20 is 25 plus 3, 28 over 15. So that's 28 over 15. 56 pi over 15 is your answer. Now the washer is, like I said, it's not too much different than the disk method. The only thing is you have to punch out that hole. And that's where you get the outer radius minus the inner radius. So if you want one nice big one big integral, here's what the integral will look like for a washer. Volume is going to be equal to pi from A to B. We're going to go outer radius squared minus inner radius squared dx. You'll see this as big R squared minus little r squared. And that just means outer radius minus inner radius. So your job, and that's all from the representative rectangle. Basically, you're going to end up finding the distance from the axis of rotation to the top, and then the distance from the axis of rotation to the bottom. Not horrific. Hopefully not. You need